A basic understanding of internal current transfer corrosion. A rectifier, buried anode bed, and protected pipeline make up a cathodic protection system. The riser brings the pipeline above ground where an insulation kit is installed, limiting the reach of the CP system to the below-ground pipeline. The cathodic protection system positively charges the ground, creating an area of corrosion protection. The footing of the above-ground piping is also in contact with this charged soil. As the anode corrodes, electrons are fed to the external surface of the buried pipe and protect areas where the coating is breached. This is done by reversing oxidation reactions between the steel and the electrolytes in the soil. The footing of the above-ground piping is in contact with the positively charged soil and becomes polarized, creating a drive for free electrons to move towards the footing. Similarly, the negatively charged pipeline creates a drive for positively charged metal ions to move across the isolation kit. This ion flow is only possible due to the high salinity of the process fluid in this pipeline. To prove this, an experiment was conducted in the lab. The buried anode and exterior of the protected pipeline are represented by two electrodes in a saltwater solution representing the soil. The internal surface of the pipe is in contact with the process fluid, which is in a separate beaker. The protected pipeline and isolated piping share contact with the process fluid across the insulation kit. Finally, the footing is in contact with the soil and electrically connected to the isolated above-ground piping. The pipeline electrodes are negatively charged, while the electrode representing the buried anode is positively charged. A positive charge is induced on the isolated piping in contact with the process fluid. Metal ions are released by the isolated piping and the buried anode, resulting in corrosion. This corrosion appears as aggressive metal loss on the above-ground piping next to the isolation kit. If you are interested in learning more about diagnosing or mitigating internal current transfer corrosion or other forms of pipeline damage, reach out to Group 10 Engineering or visit our website.